Hi all, welcome to our question paper based discussion session. Today we are going to discuss question number 37 and 38. Those who haven't watched the videos so far, kindly go back and watch all the videos. Question number 37 is usually asked from electricity chapter and 38 is from light chapter. Let's begin. Draw the pattern of lines of force due to a magnetic field through and around a current carrying loop of wire. So one question either regarding a current carrying straight conductor or a loop or solenoid will surely come. So first of all we have to draw the figure. So this will be the figure. Make sure that we have marked North Pole, South Pole and the directions. Next question is how the strength of magnetic field produced at the center of the circular loop be affected if the current passing through the loop is doubled. Current is doubled. We already know current is directly proportional to the magnetic field strength. So when current is doubled, magnetic field also will be doubled. Next one is when the radius of the loop is reduced to half. See, radius of the loop is inversely proportional to the magnetic field. So when the radius of loop is made half, then again magnetic field strength will double. So again it will be doubled. We'll go to the next question. The question is, a current through a horizontal power line flows in east to west direction. So direction of flow of current is given. It is flowing from east to west. Let's mark the directions: north, south, east and west. So here the current is flowing in this direction, east to west direction. What is the direction of magnetic field at a point directly below it and at a point directly above it? Okay, so when we get questions like this connected to current and magnetic field, we'll be using Fleming's right hand thumb rule, where the thumb points towards the direction of current and wrapped fingers points towards the direction of magnetic field. So here they are asking us what will be the direction of magnetic field on top of it and below it. So it's better we say from any one side, either from west side or from east side. When we look from east direction, our hand is like this. So when we look from east direction, the direction of magnetic field is in clockwise direction. So we can say while observing from east direction, the direction of magnetic field line will be clockwise direction. Or you can say the opposite as well. If you are observing from west, then it will be anti-clockwise direction. Next question is, list two methods of producing magnetic field. How can you produce magnetic field? First method is use a bar magnet. You will get the magnetic field. Second one is use a straight current carrying conductor through which current is flowing. It will also produce magnetic field. Or else use a solenoid. It will also produce magnetic field. So these are the different methods. Next one is one half of a convex lens. One half of a convex lens is covered with a black paper. Will this lens produce a complete image of the object? That's the first part of the question. Verify your answer experimentally. Explain your observations. So first of all the question is, will this produce a complete image of the object? Let's see. So if this is the convex lens, we have F1 here and 2F1 here. Same way, here we have F2 and 2F2. Suppose I'm keeping an object at F1, 2F1. I'm keeping my object at 2F1. So if I keep my object here, then the ray of light will go and fall here. It will come through the focus. Again, second image will come. I'll take it through the optical center. It will also come and fall here. So we'll be getting the image here. Again, if I take one more ray which is passing through the focus, it will come, then afterwards it will go parallelly. Again, that will also come and fall here. Now, suppose as per the question, if we cover half of the lens, The half of the lens is covered with a black sheet of paper or a black paper. Now, again, the rays of light will surely go. They will go and fall here itself. It will make an image here. But the intensity of the image will be reduced. That's it. Image will be there, but the intensity will be reduced because number of rays of light going and falling here will get reduced because half of the lens is already covered with black paper. Okay, so will this lens produce a complete image of the object? Yes, it will surely produce. It will produce a complete image, but the intensity of the image will reduce. It will be less. Verify your answer experimentally. So we can say like this through this experiment. Suppose if we are keeping a candle here, the candle flame will be fully visible, but if we cover half of the lens, again it will be fully visible, but the intensity of the light of that flame will be less. Explain your observations. So this is our observation. Image will be there, but the intensity will be reduced. We'll go to the next question. A straight cylindrical conductor is suspended with its axis perpendicular to the magnetic field of a horseshoe magnet. The conductor gets displaced towards the left. The conductor got displaced towards the left. So it has got displaced towards the left side when a current is passed through it. What will happen to the displacement of the conductor if, first question is, current through it is increased? We are increasing the current. We know this is based on Fleming's left-hand rule, where the current, magnetic field and the force or the direction in which the current carrying conductor will be displaced. It is based on all the three. So here, when the current is increased, obviously the magnetic field strength will increase and so it will move with greater force. Again, magnetic field strength will increase. We can say like that. The magnetic field will increase. The magnetic field increases, or we can say the force increases. The force increases. Let's go to the second question. Horseshoe magnet is replaced by another stronger horseshoe magnet. So here we are increasing the magnetic field. Again, when the magnetic field is increased, force will increase. So in the second question also, the magnetic field is increasing, so the force will increase. Next one, direction of the current is reversed. If the direction of current is reversed, everything reverses. So the conductor which got displaced towards the left side will now get displaced towards the right side. It will get displaced towards the right side. That's it. Next one, name and state the rule for determining the direction of force on a current carrying conductor in a magnetic field. That is Fleming's left-hand rule. Left-hand rule. Fleming's left-hand rule states that hold all the three fingers, that is your middle finger, your index finger and your thumb in such a way that all the three are mutually perpendicular to each other. Then your middle finger shows the direction of current and index finger shows the direction of magnetic field and thumb point towards the direction in which the conductor will get displaced or the direction of force which is acting on the conductor. So this is Fleming's left-hand rule. Please study the rule because it's very important. They might ask this for the exam. We'll go to the next one. This is the question that is asked in the CBSE model paper. Let's see the level of question. The question is like this. Magnetic field lines are shown in the given diagram. A student makes a statement that the magnetic field at X is stronger than at Y. The magnetic field at X is stronger than Y. So he is saying here it is more and here it is less. Explain with reason if the student's claim is correct. First of all, let's see whether the student saying is correct or wrong. We know the strength of magnetic field. It is determined by the degree of closeness of magnetic field lines. If we observe this area, here the field lines are much closer. They are very much closer. But here the field lines are very much far away. Comparatively, they are far away. So here, since they are far away, here magnetic field strength will be less. And here, since they are very much closer, magnetic field strength will be high. So explain with reason if the student's claim is correct. Yes, whatever the student told is correct, because the magnetic field strength is determined by the degree of closeness, of magnetic field lines. So since in the X part the field lines are closer, so the magnetic field strength will be higher. Here they are far away, so the field strength will be less. Next one is also redraw the diagram and mark the directions of magnetic field lines. We have to mark the directions here. We know that the direction of magnetic field is always from north to south, north to south, north to south. Inside the magnet, it is from south to north. Suppose if rays are coming out from this, then it is from north to south. So from north it should come out, and in the south it should come inside. So this will be the direction. So mostly question number 37 will be asked from the electricity chapter, and it will be mostly from related to the magnetic field strength and all that. Okay, so let's study in that way. Now we'll go to question number 38. 38 is asked from light chapter, the applications of light chapter, where we'll have to use a lens formula or mirror formula to find out the answer. Let's do some questions related to that. A child reads the words of a book with the help of a lens, keeping it close to the book. He finds words enlarged and erect. So the words were enlarged and erect when he gradually withdraws the lens away from the book. At one position, the words again become distinctly visible, but this time these are enlarged and inverted. Identify the type of lens. We know there are only two types of lens. First one is concave lens, then convex lens. In the case of concave lens, always only a single kind of image will be formed, which is similar to convex mirror. That is virtual and erect and diminished. Virtual, erect and diminished. But in the case of convex lens, we'll have real image, virtual image and images of all different sizes. So here, since the child is getting two different types of images, here the lens should be a convex lens. Okay, so identify the type of lens. So the type of lens is convex lens. Justify your answer. It is convex lens because here the child is getting erect image as well as inverted image. Whenever it is inverted, it is real. So it is real and inverted, virtual and erect. Those two kinds of images are obtained only by convex lens. It cannot be obtained with the help of concave lens. So the type of lens is convex lens. Next one is draw ray diagram corresponding to any one position. So in this question they have told two different positions. First one was he kept the lens very much near to the book and he saw an enlarged and erect image. So let's draw that one, or else we can keep anywhere on the principal axis and we can get an image. Let's draw any one of it. So as we did earlier, now this is F1, this is 2F1. Here also we have F2 and 2F2. When it is kept very much nearby, the object is between the optic center and F1. So first ray will take parallel. The parallel ray will go through F2 and second ray can be taken through the optic center. It will go away like this. They won't meet anywhere. But if we extend these rays, we feel like they are meeting somewhere here. So we will get an enlarged and erect image, as told in the question. So identify the type of lens, that is convex lens. Justify your answer. It's because convex lens form both the type of images. Then draw a ray diagram. So we have drawn one ray diagram as well. We'll go to the next question. So for this question we have a subpart as well, A, B, C or D. So in question number 38, for the subpart C, we'll have an option. A and B are compulsory, but C part is not compulsory, it's optional. Either C or D, it's our choice. So here we have the C question, an object of height 4 centimeter. So object height is 4 centimeter. height of the object is 4 centimeter, is placed at a distance of 20 centimeter. So object distance is 20 centimeter. We know object is always kept towards the left side. So by sign convention, we should write minus there. From a concave lens of focal length 10 centimeter. It's concave lens, so whenever it is concave, the focal length should be minus, negative. So it is minus 10 centimeter. Use lens formula to determine the position of the image formed. We have to find out the image distance. Also the nature, either we can find out the magnification or just by using the values given and the value that we get, we will be able to predict it. Let's see. So first of all, let's find out the image distance. For that, we should use the lens formula. We know the lens formula, 1 by V minus 1 by U is equal to 1 by F, or 1 by F is equal to 1 by V minus 1 by U. Let's substitute the values. V is not known, 1 by V minus 1 by U is 1 by minus 20. Don't miss this one. Since already one minus is there, we will forget to write this minus here. So usually our answer will be wrong. Don't do it like that. 2 minus will come there. By 1 by F. F is minus 10. I'll keep this 1 by V here. So 1 by V is equal to 1 by minus 10. This minus into minus becomes plus. When this plus goes here, it will become minus again. Minus 1 by 20. So again, 1 by V is equal to, I'll take minus outside. That is 1 by 10 plus 1 by 20. So if I multiply here with 2 and here also with 2, then I'll get 1 by V is equal to 2 plus 1, that is 3 divided by 2 plus 1, that is 3 divided by, here it's 20, here also it's 20, common denominator, I'll write it as it is 3 by 20. So therefore, V is equal to, we'll take a reciprocal on both the sides. So V is equal to 20, minus is common here, 20 minus 20 divided by 3. So we will get V is equal to minus 6.66. Everything is given in centimeter. So here V is also centimeter. If needed, we can round it off to V is equal to minus 6.67 centimeter. So answer is 6.67 minus 6.67 centimeter. Now we see the object was kept towards the left side. Here we have a minus sign. It means that the object was kept towards the left side. And we got the image also towards the left side. So which means the object and the image both are on the same side. And the lens used is a concave lens. As we already know, in the case of concave lens, we'll always get diminished image. The concave lens will give diminished image which is virtual and erect on the same side, similar to a convex mirror. Okay, so since it is concave, now here since we are getting the image also on the same side, this image is not real, it is virtual. A virtual image is always erect, and in the case of this one we get a diminished image. So this is the property image form. If needed, we can use the magnification formula as well. M is equal to V by U. We will get our V value as minus 6 point. So from this we know that anyway 20 won't go in 6. It will be a value less than 1. So if the value is less than 1, the image is obviously diminished. And it's virtual and erect because here there is no minus sign. We know in magnification, if the value's sign is positive, then it's a virtual and erect image. Virtual, erect. And if it is a negative value, then it is real and inverted. The value is equal to 1, then it is same size. If the value is greater than 1, then enlarged. If the value is less than 1, it is diminished. So as per all this, here it is virtual, erect and diminished. This is the nature of the image formed. We'll go to the OR question, that is D. Here, a converging lens. In the previous question it was concave lens, but here it is converging lens. We know converging lens is convex lens. We should be knowing that converging lens is a convex lens. Has a focal length of 12 centimeter. So focal is 12, which means plus 12 centimeter. Convex is always positive. Calculate at what distance should the object be placed. So here we have to find out the object distance from the lens so that it forms an image at 48 centimeter. So image distance is given as 48 centimeter on the other side of the lens. What is the nature of the image formed? So here this is convex lens, that is converging lens, and they are saying that the image is formed on the opposite side. So anyway, it's a real image, real and inverted image. Anyway, let's find out the object distance. For that we'll use the lens formula. 1 by V minus 1 by U is equal to 1 by F. 1 by V is 1 by 48 minus 1 by U is 1 by U itself is equal to 1 by 12. I'll keep this 1 by U here. 1 by U minus 1 by U is equal to 1 by 12 minus 1 by 48. So if I multiply everything with minus, then I'll get 1 by U is equal to, here it will become plus, here it will become minus. So I'll write like 1 by 48 minus 1 by 12. Here I know that 12 into 4 times will be 48. So I'll just multiply with 4. Now I'll get 1 by U is equal to 1 minus 4. That is 1 minus 4 divided by 12 into 4 is 48. Here also it's 48, common denominator. So 1 by U is equal to minus 3 by 48. If I take the reciprocal on both the sides, U is equal to minus of 48 by 3. U is equal to minus of 3 will go 1 time in 4 and 3 will go 6 times in 18. So U is minus 16. Everything is in centimeter. So here it is also centimeter. So object distance is minus 16, which is on the left side of the lens, and image distance is plus 48, which is on the right side of the lens. So we are getting an image on the right hand side. So here the image is real. It is inverted because we are getting it on the screen, and it is enlarged. If we have doubt in that, we can find out magnification. Magnification is equal to V by U. Here V is 48 and U is minus 16 into 3. Here we know that 16 into 3 is 48. So minus 3. As we told earlier, it's a negative sign. Means it is real and inverted. And the value is 3. 3 is greater than 1. So since it is greater than 1, it is enlarged. So the nature of image is real, inverted and enlarged. And the object distance is minus 16 centimeter. We'll go to the next one. Here we have few questions from the electricity chapter as well. Usually it will be asked from the light chapter, but still we'll just practice some questions from electricity chapter also. The question is like this: 2 or more resistances are connected in series or in parallel or both, depending upon whether we want to increase or decrease the circuit resistance. We already know that one. And now a figure is given here. Then the 2 or more resistances are said to be connected in series if the current flowing through each resistor is same. We already told that in series connection, current is same and potential difference or voltage is different. But in parallel connection, the opposite happens. In parallel connection, current is different, voltage is same, potential difference is same. So now first question: when the 3 resistors, each of resistance R ohm, are connected in series, what will be the equivalent resistance? So here all the 3 resistors are R ohm, R ohm, R ohm, R ohm. So what will be the equivalent resistance? It is series connection. We know in series connection, we'll just add all the resistors. R1 plus, R2 plus, R3. Here resistance 1 is R ohm, resistance 2 is also R ohm, and 3 is also R ohm. So our total resistance will be 1R plus 1R plus 1R, that is 3R ohm. This much will be the resistance. So this is the first. Second one, there is a wire of length 20 centimeter. So they are speaking about a wire, a long wire of length 20 centimeter, having resistance 20 ohm. So this is having a resistance of 20 ohm. It is cut into 4 equal pieces. So it's cut to 4 equal pieces. Then it is joined in series. Then what will be the equivalent resistance? Here we know resistance and length are directly proportional. If we have 10 ohm resistance and if it is cut into 2 equal pieces, then each piece will be 5 ohm, 5 ohm. Here actually it is 20 ohm resistance. So this 20 ohm is cut into 4 equal pieces. So 20 divided by 4. 20 divided by 4 is 5 ohm. So our each piece will be 5 ohm, 5 ohm, 5 ohm and 5 ohm. So here what will be the equivalent resistance? Equivalent resistance, it's the same equation. R is equal to R1 plus R2 plus R3. So R1 plus R2 plus R3. Here each resistance is 5 ohm. So it is 5 plus 5 plus 5. Total 15 ohm. So our total resistance, equivalent resistance will be 15. That's it. As we saw earlier, even here also, the third question is optional. Let's do the third one. In the following circuit, find the equivalent resistance between A and B. Each resistor is 2 ohm. So here each resistor is 2 ohm. Even though it's given in this way, if we just observe, we'll understand that it's connected like this, which means it is a series connection. In series connection, it is just R1, R2 plus, R3 plus, R4 plus, R5. Here we have 1, 2, 3, 4, 5. 5 resistors. Each one is 2 ohm. So let's add all this. 2 plus, 2 plus, 2 plus, 2 plus, 2. 1, 2, 3, 4, 5. So 5 to 10. We'll get 10 ohm. 10 ohm is the answer. Now in the second one, in the given circuit, what is the current in each resistor? In parallel connection, voltage is same, current is different. In series connection, current is same, voltage is different. Here, this is a series connection. Since it is series connection, here the current will be same. So, if we find out the total resistance here, then Rs or R total will be equal to R1 plus R2 plus R3, that is equal to 1 plus 2 plus 3. So we'll get 6 ohm. So 6 ohm is the effective resistance here, and the total voltage V total, the difference is 18 volt. So if we find out the total current, that total will be current across each one of these resistors, because in series connection current is same. So using Ohm's law, V is equal to IR. Let me substitute all the values. Here V is 18. Current is unknown. We are going to find out that. Resistance is 6 ohm. So now if I keep here 18 divided by 6. So 6 3s are 18. So I'll get I is equal to 3 ampere. This is the answer. So I'll get current is equal to 3 ampere. A student fixes a sheet of white paper on a drawing board using adhesive material. She places a bar magnet in the center of it and sprinkles some iron filings uniformly around the bar magnet using salt sprinkler. On tapping the board gently, she observes that the iron filings have arranged themselves in a particular pattern. We already know this. Let's come to the question. What makes iron filings arrange in definite pattern? So why is it arranging itself? It is because if we are keeping a bar magnet, then a bar magnet will already have its influence around it. That is called the magnetic field. So because of the magnetic field, because of that magnetic field's force or its influence, the iron filings will arrange itself in a pattern. So it is arranging in a definite pattern because of the magnetic field line or the influence of the magnetic field. That is why it's happening, or because of the force of the magnet. Now, draw a diagram to show this pattern of ion filings. We have already done this so many times. So if this is North Pole and this is South Pole, then it's from north to south. It's also from north to south. Again, from here the magnetic field lines will be going outside. So direction is from north to south, again north to south, north to south. It is coming out to south. It will be like this. Next is, how is the direction of magnetic field at a point determined using the field line? So how will we get the direction? How did we decide the direction? To decide the direction, we can use a small compass. A magnetic compass can be used. So when we keep the compass at a particular point, then look where its north pole is pointing. So if its north pole is pointing towards this direction, then we have to keep the compass there. Then again, the north pole will point towards a particular direction. Keep it there. So once we keep it like that and keep on going, we'll reach the opposite pole. Like this, we'll be able to identify the direction of the magnetic field. Next one is, why do two magnetic field lines not cross each other? Why magnetic field lines will not cross each other? So just by using this compass needle itself, we'll be able to say the answer for this, because once we keep the compass needle here, the north pole will always show a single direction. If they have to cross each other, then the magnetic compass should show two directions, which is not possible. So why do two magnetic field lines not cross each other? It's not possible. And when we try with a magnetic compass, we'll always get a single direction. It's not possible to have two directions at a time for a magnetic compass. So it's not possible. We'll go to the next question. If two or more resistances are connected in such a way that the same potential difference gets applied to each of them, then they are said to be connected in parallel. Just now we said that in parallel connection, potential difference will be same. The same potential difference will be there. Potential difference or the voltage will be same in parallel connection. Here they have given a parallel connection, and the current flowing through two resistances in parallel is however not same. We know that current will not be same here. Here the potential difference is same and current will not be same. Okay. When we have two or more resistances joined in parallel to one another, then the same current gets additional paths to flow and the overall resistance decreases. We know this. First question, three resistances, 2 ohm, 6 ohm and 8 ohm are connected in parallel. Then what will be the equivalent resistance? So here in this circuit, instead of R1, R2, R3, we have 2 ohm, 6 ohm and 8 ohm which are connected in parallel. So we know 1 by Rp is equal to 1 by R1 plus by 2 plus 1 by R3. When we substitute, 1 Rp is equal to 1 by 2 plus 1 by 6 plus 1 by 8. So now 1 by Rp is equal to, either we can cross multiply or make common denominator, then we'll be able to get the answer. Anyway, I'll cross multiply. 1 to 6 is 6 plus 1 2 is 2 by 2 6 are 12. 12 plus 1 by 8. So again 1 by R is 6 plus 2, it is 8 by 12 plus 1 by 8. So if needed, I can use it. 1 by Rp is equal to 2 4s are 8, 2 6 are 12, 2 2s are 4, 2 3s are 6. So I can write like 2 by 3 plus 1 by 8. Now I'll just cross multiply again. 1 by Rp, 2 2 are 16 plus 3 1 is 3 by 3 8s are 24. So I'll get 1 by Rp equal 19 by 24. So I can write it like 19 by 24. In second question, a wire of resistance 12 ohm. 12 ohm is cut into 3 equal pieces. Just now we have seen similar question. If a same piece of wire is cut into 3 equal pieces, its total resistance is 12 ohm. It's already told. So if we divide 12 by 3, then each piece will be 4 ohm. So each piece will be 4 ohm, 4 ohm, 4 ohm resistance. Then they are twisted their ends together. Then what will be the equivalent resistance? So this each piece is separated like this and their ends are twisted together. What kind of connection is this? This is a parallel connection. So in parallel connection, 1 by R equal to 1 by R1 plus 1 by R2 1 by R to 3 by 4. Therefore, in reciprocal, Rp is equal to 4 by 3. Rp is equal to 4 by 3. In the third question, as usual, it's an OR question. Let's see the first one. 3 resistors are connected as shown. Calculate the equivalent resistance A and B. So between A and B, what is the equivalent resistance? Let's see. Here we might think like the figure is a little confusing, but actually here we have a resistor at the center, another resistor here, and another resistor here. Actually, all the 3 are connected parallelly. Since they are connected parallelly, 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by Rp is equal to 1 by 1 plus 1 by 3 plus 1 by 6. 3 and 6, we can make it common. 3 into 2, 1 into 2. I'll keep that 1 as it is. So 1 by Rp is equal to 1 plus 1 into 2 is 2. 2 plus 1 is 3. 3 divided by common denominator 6. 3 by 6. So now again 1 by Rp is equal to 1 into 6 is 6 plus 3 into 1 is 3 divided by 6. So 1 by Rp is equal to 9 by 6. When we take the reciprocal, Rp is equal to 6 by 9. When we cut it with 3, 3 2s are 6, 3 3s are 9. 2 by 3 ohm is the answer. So effective resistance in this parallel connection, it is 2 by 3 ohm. Let's go to the OR question. In OR question, find the current in each resistance. We have to find out the current in each resistor, here, 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 and here. We know this is parallel connection. In parallel connection, potential difference is same, but current is different. To find out the total current, first of all, let's find out the effective resistance. Here, the resistors are cut in parallel. So 1 by Rp is equal to 1 by R1, 1, 2, 3, 4. 4 resistors are there. So 1 by R2 plus 1 by R3 plus 1 by R4. So 1 by Rp is equal to 1 by 12 plus 1 by 12 plus 1 by 12 plus 1 by 12. So altogether 1 by Rp is equal to 1, 2, 3, 4. That is 4 by 12. When we take the reciprocal, Rp is equal to 12 by 4. That is equal to 3 ohm. So we got the total effective resistance as 3 ohm. So we have the total resistance in our hand, and we have the voltage as well. The potential difference is also given. As per Ohm's law, V is equal to I into R. So V is 3. The total current here is, we have to find out that one, and the resistance, effective resistance is 3. So I is equal to 3 by 3. So here total current will be 1 ampere. 1 ampere is the total current available here. This 1 ampere is divided into 4 equal parts because all the 4 resistors are equal. So here each resistor will have a current of, the first resistor will have 1 1 by 4th of this one. So 1 by 4 of 1 is 1 by 4 itself. It will be 1 by 4 ampere. Then I2 current will be 1 by 4 ampere. I3 current will be 1 by 4 ampere. I4 current will be 1 by 4. Altogether, it will be 1 ampere. Either we can do it in this way, or each one, taking each one also, we'll be able to see. I'll do one and show. Just consider the first resistor. So there, the potential difference will not change. So V is equal to 3 volt, and the potential and the resistance R is equal to 12. Just taking the first resistor, we have to find out the current. So we know I is equal to V by R. V is 3 and R is 12. 3 one time, 3 4 times. So 1 by 4 ampere. Any method is fine. So across each one we'll have 1 by 4 ampere. Or else if we do like this, altogether the current is 1 ampere. So it has to be divided into 4 equal parts. So 1 by 4 into 1 will have 1 by 4 ampere. So this is the answer. Now we'll go to the CBSE paper and we'll see this question in the CBSE paper. Usually this will come from the light chapter. Let's see the question there. Here, it's a case-based question. The above image is that of a digital single lens reflector DSLR camera, which are used to take higher resolution photographs by professional photographers. The second image of the above two is a schematic diagram of how an image is formed on the sensor of the camera. Based on your understanding of the lenses, answer the following questions. So here we can see that object is here, an object is here, and this object's image is formed, a real and inverted image is formed inside the camera through a convex lens. We are able to see these many things here. Let's go to the first question. What type of lens is used in DSLR camera shown in the image? As we told just now, it is convex lens. What type of image is formed on the sensor? It is real, is inverted, and is diminished. Real, inverted and diminished. Okay. Next question is attempt either C or D. It's an optional question as we have seen now. So it requires some space. Let's take these questions to the slide. We'll solve it there. A photographer is using a DSLR camera with a lens of focal length 50 millimeter. So the focal length is 50 millimeter. To take a close-up photograph of a small object, the lens projects an image onto the camera sensor that is located 60 millimeter behind the lens. Image is coming and falling on the screen which is 60 millimeter behind the lens, which means indirectly they have given us the image distance, that is 60 mm, 60 millimeter. Calculate the object distance. We have to find out the object distance. A direct question. Here the lenses are used inside the camera. Here one lens is used. From this itself we'll understand, since the focal length is a positive value, it's a convex lens, and in the image also we have seen that one. So now we have to find out the object distance. We know the lens formula, 1 by V minus 1 by U is equal to 1 by F. Substitute all the values. 1 by V is 1 by 60 minus 1 by U, we don't know, is equal to 1 by focal length is 50 mm. Now I'll keep this 1 by U here is equal to 1 by 50 minus 1 by 60. I'll multiply everything with a negative, so I'll get 1 by U is equal to, this negative becomes positive, this one becomes negative, so I can write it like 1 by 60 minus 1 by 50. So 1 by U is equal to 1 into 50 is 50 minus 1 into 60 is 60 divided by 5, 6 are 30. 2 more zeros are remaining there. So 1 by u is equal to 50 minus 60. We'll get minus 10. Minus 10 divided by 3000. 0 and 0 got cancelled. So now u is equal to, take the reciprocal, that is minus 300. Everything is given in millimeter, so object distance is also millimeter. Minus 300 millimeter. This is the object distance. Calculate the object distance was the question. We got the object distance as minus 300 millimeter. We'll go to the OR question. A photographer is using a DSLR camera to take a picture of a flower. The flower is positioned 150 millimeter away from the camera lens. So object distance is given as 150 millimeter. The actual height of the flower is 80 millimeter. So height of the object is given as 80 millimeter. The image height formed on the camera sensor is measured to be 20 millimeter. So height of the image is 20 millimeter. Calculate the focal length of the camera's lens. We have to calculate the focal length. Okay. Here one more thing is, here it's told like the camera height formed on the camera's sensor is measured as 20 mm. And in the image we have already seen that the image formed is a real and inverted image. So the height of the image will be a negative value. If we don't give that here, our answer will be wrong. Again, object is kept at 150 millimeter. So object is always kept towards the left side. So there also we should give a negative sign. Now, if we use the lens formula, we should be able to get the answer. Let's see, 1 by v minus 1 by u is equal to 1 by f. Here we don't have v and we don't have f also. So we can't substitute directly here. But before that, using this height of the object and height of the image, we should do something to get one of the variables. So let's see, we know the equation for magnification. Magnification is equal to v by u in the case of lens. If it is mirror, it is minus v by u. Or we can also write it like height of the image by height of the object. Let's substitute the values that we have here. V is not known. Let me write v itself by u value is minus 150. That is equal to just minus 20 divided by height of the object is 80. 0, 0 cancelled. 2 goes 1 time in 2, 2 goes 4 times in 8, so it will be minus. So if I cross multiply, I'll get 4v is equal to 150. Again, v is equal to 150 divided by 4. If I just cut it, I'll get 2 into 75, 2 into 2. So for me, I got image distance v is equal to 75 by 2. I need not convert this to decimal because this is not the answer that they're asking for. This is a step that we are getting in between. Now I'll use this one here. So v is 75 by 2. So 1 by v is 2 by 75 minus 1 by u. U value is minus 150 minus 150 is equal to 1 by f. Now 2 into minus 150. See, minus and minus will become plus. So this is 2 by 75 plus 1 by 150 is equal to 1 by f. We know 75 into 2 is 150. Let me make the denominator same. I'll multiply here with 2 and here also 2. So it will be 2 to 4. 4 plus 1, 5. It will be 5 by 150 is equal to 1 by f. 5 goes 1 time in 5. 5 goes 3 times in 15. So it will be 30. 1 by 30 is equal to f. Therefore, F is equal to reciprocal 30. Everything is in millimeter, so our answer will be 30 millimeter. F is equal to 30 millimeter. That's it. So now we have discussed question number 38 as well. Now only one more question is remaining, that is question number 39. By that, we'll have a clear idea about the question paper. Let's see. Thank you.